The robots never stop moving. 24 hours a day, 7 days a week, massive mechanical arms swing through precise arcs, welding, lifting, and assembling. This is Tesla's Gigafactory in Nevada, where a new Model Y rolls off the production line every 10 seconds. What started as Elon Musk's ambitious vision to revolutionize car manufacturing has become the most automated vehicle factory on Earth. The scale is staggering. This single facility can produce 500,000 cars annually, while manufacturing its own batteries, motors, and even seats. The real story isn't just about building cars. It's about building the future of manufacturing itself. Tesla's manufacturing revolution begins thousands of miles away from Nevada, in mines and processing facilities scattered across the globe. The journey starts deep underground in lithium mines across Australia and Chile, where massive excavators extract the white metal that powers every Tesla battery. These lithium deposits get processed into battery-grade lithium carbonate through a complex chemical refinement process that takes months to complete. Meanwhile, cobalt mining operations in the Democratic Republic of Congo extract the crucial element needed for battery cathodes. Tesla has worked to reduce cobalt usage, but the metal remains essential for battery stability and performance. The cobalt undergoes multiple purification stages before it meets Tesla's strict quality standards for automotive applications. Nickel sourcing presents another challenge entirely. Tesla sources high-grade nickel from mines in Indonesia, Canada, and Russia. The nickel gets processed into nickel sulfate through a specialized hydrometallurgical process that removes impurities down to parts per million levels. This ultra-pure nickel becomes the foundation for Tesla's high-energy battery cells. The steel story is equally complex. Tesla uses specialized high-strength steel alloys for the vehicle frame and body panels. These steel grades come from mills in South Korea and Germany, where the metal gets rolled to precise thicknesses and treated with protective coatings. Each steel coil must meet exact specifications for tensile strength, formability, and corrosion resistance. Aluminum sourcing adds another layer of complexity. Tesla sources aluminum sheets and extrusions from suppliers across North America and Europe. The aluminum gets processed through multiple stages, including heat treatment and surface preparation, before it arrives at the Gigafactory. Quality control teams test every shipment for composition, thickness, and surface quality. The logistics network coordinating these materials operates like a precision instrument. Temperature-controlled containers ship battery materials to prevent degradation during transport. Steel and aluminum shipments require careful handling to prevent scratches or dents that could compromise structural integrity. Real-time tracking systems monitor every shipment from source to factory, ensuring materials arrive exactly when needed for production. The heart of Tesla's Gigafactory is a manufacturing system unlike anything seen before in automotive production. The process begins in the battery production area, where raw materials transform into the power source for every Tesla vehicle. Massive mixing tanks blend lithium, nickel, and cobalt compounds with precise ratios measured to the gram. The mixture gets heated to exact temperatures while mechanical stirrers maintain perfect homogeneity throughout the batch. From these mixing tanks, the battery slurry moves through automated coating machines that apply the active material to copper and aluminum foils. These coating machines operate at incredible speeds, laying down material layers just micrometers thick across foils that stretch for miles. Laser measurement systems continuously monitor coating thickness, automatically adjusting application rates to maintain perfect uniformity. The coated foils then enter massive drying ovens that remove every trace of moisture from the battery materials. These ovens maintain temperatures within 1 degree while moving the foils through at precisely controlled speeds. Any variation in temperature or timing could compromise battery performance, so sensors monitor conditions thousands of times per second. Battery cell assembly happens in clean rooms that rival semiconductor facilities for cleanliness. Robotic systems stack the dried electrode materials with separator films, creating the layered structure that defines each battery cell. These robots work with incredible precision, placing each layer within fractions of a millimeter of its target position. The stacked cells then get inserted into aluminum casings and filled with electrolyte solution through automated dispensing systems. The vehicle assembly line operates with equal precision but on a much larger scale. Massive stamping presses shape steel and aluminum sheets into body panels using forces exceeding 2,000 tons. These presses operate in sequence, with each press adding more complex curves and features to the metal. The finished panels emerge with tolerances measured in tenths of millimeters. Body assembly brings together hundreds of individual components through a choreographed dance of robotic welders. More than 400 robots work in perfect coordination, each programmed with thousands of weld points. The robots move with fluid precision, their welding torches creating showers of sparks as they join body panels together. Quality sensors check every weld in real time, flagging any irregularities for immediate correction. The paint process represents another marvel of automation. Robotic paint applicators spray each vehicle with multiple coats of primer, base color, and clear coat. The robots follow precise patterns programmed to ensure complete coverage while minimizing waste. Paint booth conditions remain constant temperature, humidity, and airflow, all controlled to the exact specifications needed for perfect finish quality. Final assembly brings together the painted body, battery pack, motors, and thousands of smaller components. Robotic systems install heavy components like battery packs and motors with millimeter precision. Human workers handle more delicate tasks like interior installation and final quality checks, but even these processes follow strictly controlled procedures. Quality control systems monitor every step of production through thousands of sensors and cameras. Machine vision systems inspect paint finish, panel gaps, and component alignment. Electrical testing systems verify that every circuit functions correctly before the vehicle leaves the production line. Any vehicle that doesn't meet Tesla's standards gets pulled from the line for additional attention. The entire system operates under computer control, with production management software coordinating every robot, conveyor, and quality station. This software tracks each vehicle through every step of production, maintaining complete records of every component and process used in assembly. The system can identify and correct problems within seconds, maintaining the rapid pace that allows Tesla to build a car every 10 seconds. Tesla's manufacturing revolution extends far beyond the Nevada Gigafactory, spanning a global network of production facilities designed to serve regional markets with maximum efficiency. The company operates major gigafactories in Shanghai, Berlin, and Texas. Each tailored to local market demands and regulatory requirements while maintaining Tesla's exacting quality standards. The Shanghai Gigafactory represents Tesla's most ambitious international expansion, capable of producing over 750,000 vehicles annually. This facility incorporates lessons learned from Nevada, featuring even more advanced automation systems and streamlined production flows. The Shanghai plant produces vehicles specifically for the Chinese market and exports throughout Asia, reducing shipping costs and delivery times compared to importing from the United States. Tesla's Berlin Gigafactory serves European markets with a focus on the Model Y crossover, the company's highest volume vehicle. This facility includes advanced battery production capabilities and incorporates sustainable manufacturing practices required by European environmental regulations. The Berlin plant uses renewable energy sources and implements closed-loop water recycling systems that minimize environmental impact while maintaining production efficiency. The Texas Gigafactory, Tesla's newest and largest facility, spans over 2,400 acres and focuses on Cybertruck production alongside Model Y assembly. This facility incorporates Tesla's most advanced manufacturing technologies, including new structural battery pack designs that simplify assembly while improving vehicle performance. The Texas plant also serves as Tesla's primary facility for semi-truck production, targeting the growing commercial electric vehicle market. Regional production centers complement these major facilities, handling final assembly and customization for specific markets. These smaller facilities receive partially assembled vehicles and battery packs from the main gigafactories, then complete final assembly with region-specific components like charging ports, infotainment systems, and regulatory equipment. Capacity scaling during high-demand periods demonstrates Tesla's manufacturing flexibility. The company can rapidly increase production by extending operating hours, adding temporary workforce, and optimizing production line efficiency. During Model Y launch periods, Tesla successfully ramped production from pilot builds to full-scale manufacturing within months, rather than the years typically required by traditional automakers. The distribution network ensures vehicles reach customers within days of production completion. Tesla's direct sales model eliminates traditional dealer inventory, allowing the company to ship vehicles directly from factories to delivery centers located near major population centers. This approach reduces inventory costs while providing customers with vehicles built specifically to their configuration preferences. Quality consistency across all global facilities remains paramount to Tesla's brand reputation. The company implements identical quality control procedures, testing protocols, and manufacturing standards at every location. Regular audits and cross-facility training programs ensure that a Model Y built in Shanghai meets the same quality standards as one assembled in Texas or Berlin. This automated precision creates millions of vehicles annually while redefining what's possible in modern manufacturing. Tesla's Gigafactory network represents more than just car production, it's a complete reimagining of how complex products get built in the 21st century. Subscribe for more manufacturing secrets and watch our next video exploring how traditional automakers are racing to catch up with Tesla's production innovations.